So welcome everyone. Welcome to tonight's BCRES presentation. So tonight we have fleet electrification and microgrids, a perfect combination. We have Namit Singh of Microgrid Labs and Bill Patterson of Mobility Services speaking together, and they'll be discussing their efforts in combining microgrids with fleet electrification in an effort to cut operational expenses and achieve Colorado's sustainability goals. Just as usual, quick agenda for tonight after I run through these announcements, which will not run 15 minutes, we'll run closer to 5. Namit and Bill will give their presentation, which will be followed by a live Q&A. So I wanted to just give one quick shout out to a couple of our different sponsors, including Solaris Energy, the University of Colorado, and then Ryan Ludlow, our videographer, who is part of the BCRES team. Ryan, in normal times, films all our events and puts them on the CRES website and YouTube page, so you guys can either rewatch our events or attend them after the fact if you're not able to attend them when they happen live. Also, with the University of Colorado, we typically host our events on the campus, again, in normal times. Now we're obviously in a virtual format, but hopefully before too long, we'll be back to having our presentations live on the University of Colorado campus. So for those of you who have never attended one of our events before, this event is being put on by the Boulder Chapter of the Colorado Renewable Energy Society. We're one of 5 chapters that make up the Colorado Renewable Energy Society, all of which's goal and mission is to raise awareness on the use and adoption of renewable energy and energy efficiency techniques, technologies, and what have you. We cover all kind of topics in that scope, even if it's not perfectly renewable energy related, which, covering stuff like climate change and sustainability. Typically, right now it's a little different, but we are always happy to have volunteers and people who are interested in joining our steering committee and helping out plan and run and organize these events. We are always accepting new members of CRES. You could sign up on the CRES Energy website with the fee information all listed there. And that gives you access to all CRES events for all the chapters across the state. And also, if you want to follow a lot of our relevant content, we post a lot of stuff, obviously, to Meetup, like these events, but we're pretty active on Facebook and Instagram, as well as our email newsletter as well. Always covering topics related, again, to renewable energy, energy efficiency, and what have you. And again, too, something that we've greatly missed from doing these events in person is trying to get people networked together who are either looking for clean energy employment or have positions in the clean energy field that they're looking to fill. I won't keep this slide up too long here, but if you want, just ping me or anyone on our team, and I'm happy to send you these resources to you after the presentation. All right. So, quick little bit about the speakers. Namit Singh is the co-founder of Microgrid Labs and holds a PhD and master's in mechanical engineering. He has more than 10 years of experience with microgrids and is now working towards combining microgrids with electric vehicle fleet electrification. Bill Patterson, who is joining him, is currently the Chief Financial Officer of Via Mobility Services, which is a nonprofit transportation organization serving those with limited mobility options. The organization itself provides services around the metro area in Denver and has been operating in the area for the last 40 years. So very excited to have both speakers come here today. But without further ado, I will hand things over to Namit and we'll get the presentation started.
All right, sounds good. Thank you so much. Hello, everyone. Great to be here. Great to be talking about some of the exciting work that we've been doing in this area, and glad to be here and to be able to talk about it. So as the topic suggests, we will be talking about fleet electrification, and lately we've been working on integration of fleet electrification with microgrids, and on the microgrid side, our focus has been renewable intensive microgrids. So as a company, we have been focused on campus level and city level microgrids, doing feasibility studies, and from there transitioning into the design and implementation of microgrids. So a few years back, we started looking at this upcoming issue or problem of fleet electrification, and as the penetration of electric vehicles go up, and at the same time the size of the vehicles start going up, not just light duty vehicles, but medium duty and heavy duty start getting electrified. So we identified and felt that that would mean that a very detailed planning needs to be done for the charging infrastructure, for operations, and all the details associated with fleet electrification. And that is where we started focusing on and have been doing that for several years. So glad to be here. As Chris mentioned earlier, so we will be talking about Via Mobility Services. That is a local fleet operator here in Boulder. You guys might have seen their vehicles going around. You guys might have also definitely seen the Hop bus, which is one of the heavy duty buses. That the Hop route is what Via operates for the city of Boulder. So as we go through the presentation, we'll talk more about it. But again, feel free to ask any questions. I'll just do a general introduction of the topic, of the area, and then some specifics about the project. So, okay, how do I move this forward? Perfect. So, electric vehicles, as you guys might be aware and seeing, that this has been increasing at a very rapid pace over the last couple of years, and this is expected to be just the start. And along that same route or same line, it is going to really kind of, we can say, explode in the next decade or so. Earlier, it started off with Tesla and Nissan doing a few vehicles here and there, but now every single manufacturer, and this is just a short list, and not just in the light duty vehicle, but medium duty, in heavy duty, in buses, in trucks, in vans, every single type of vehicle that we can think of. Now there are companies who are either transitioning to building electric, or there are companies who were started from scratch, completely building electric vehicles. So it is not a concept anymore. It is not at a stage where it's like, yeah, some people are doing it, but it's happening at a very, very large scale. So within that, we are focused on fleet electrification. We are not focused on private vehicles, private light duty vehicles. We are focused on fleet electrification. So the segments might be buses, transit buses, school buses, airport buses, any type of buses that carry passengers. Commercial trucks, that is what is now. There is huge push towards that, and we are seeing there are several companies that are manufacturing it. And then light duty, but again fleets. So these may be cities are operating their fleets. There are several other agencies that are operating their fleets. So this is what we are focused on, and we feel that this is what has the largest impact. So one of the main things when you're talking about fleet electrification is the transportation agency or the fleet operator is now responsible for selecting the right vehicles, procuring the right vehicles, setting up the charging infrastructure, taking care of the electrical infrastructure, energy infrastructure, and all of these are dependent on each other. The decisions that they make for each one of these is heavily dependent on each other. In today's date, most of the fleet operators are experts in transportation, but now they are being expanded into or pushed into looking into the electricity side and the energy side of things as well. Let's take Via Mobility as an example, operated by Via, and this particular fleet, which is the heavy duty one, Hop. Everyone might have seen, at least people that live in Boulder might have seen this going around. So now when Via and City of Boulder plans to electrify, they have to think about what buses to buy, what charging infrastructure to set up, and what is the energy mix or the electrical infrastructure needed for that. So for doing that, you have to do a detailed analysis of routes, and out of those, identify that which are the routes which are suitable for electrification, because there are restrictions. It's not like a one size fits all, buy an electric bus and it can do anything and everything. So from that point of view, this is restricted in a way, in a few ways. So you have to really identify which are the routes that you can electrify. Based on that, now which are the buses that you buy, what is the battery size on it, what is the motor size on it, and all the details associated with it. Then once you're looking at the electric fleet, what type of charging infrastructure is needed, how many chargers, what size of chargers, because now when you're talking about these large vehicles, you cannot get away with the level 1 or level 2 or even other slow chargers. You are now talking about fast chargers, mostly DC fast chargers, where each charger and each of these electrified heavy duty vehicles, just to give an idea, each one of them is equivalent to about 20 to 25 houses, powering about 20 to 25 typical houses in the US. So when you are talking about a fleet of 100, 200, 500 vehicles, so now you are talking about the charging infrastructure and the energy and electricity infrastructure at a completely different scale, which was not thought of earlier. So all of these things bring in a lot of challenges. So the main thing is, when you are taking on a project like this, which is such a big project, you have to consider all the factors associated with it. You have to go through a very detailed transition planning, starting from, as I was explaining, you have to look at the routes that you are operating. For each route, do detailed analysis for your mobility data and do modeling associated with that. Based on that, you get the motor sizing, battery sizing. Based on that, charging infrastructure sizing. So the point I'm trying to make here is that it is not something as simple as, oh, I want to electrify, let me go and buy a vehicle. So it is a very, very detailed and an involved process. Now, the challenge there is that all the sub factors that we looked at, those are interrelated and dependent on each other in such a complex way that you cannot go ahead and make a decision that let me buy one bus and then I will figure out what is the charging infrastructure, or then I will figure out what is the energy mix or the cost associated with that. You really have to take all of that into consideration during the planning phase. Otherwise, there is a very good chance that the projects might fail. So from that point of view, the complexity and the detailed analysis that needs to be done during the planning phase itself is very, very critical. So again, as I'll just quickly go through it, not get into details, but when you're talking about battery sizing, you have several factors like what routes are you operating on. The challenge with electric vehicles is, unlike internal combustion engine vehicles, where the same vehicle can operate anywhere and everywhere in pretty much the same and give the pretty much the same performance. The challenge with electric vehicle is the exact same bus. As an example, the way it will operate in Arizona will be completely different from the way it will operate in Chicago, say, for example. So from that point of view, and again, within that city also, the different routes in which it operates is also what determines that how the performance of the vehicle will be. So the challenge with that is you have to now you cannot just take the manufacturer provided information that this is what the efficiency of the vehicle will be and hence the energy consumption, but you really have to consider that for your location, for your route, for the time in which it is operating, and all of these factors put in together, that is what determines whether this vehicle is fit for you or not, whether this charger is fit for you or not, whether this charging infrastructure, whether this mix of energy resources is a fit for your application or not. So it's a very, very customized detailed planning that needs to be done. The challenge that the industry has seen again and again, unfortunately, is if the planning was not done right and these decisions were not taken in the right way, the project kind of tends to become a failure. So here is one example locally. RTD, who initially the thought was that their operating cost will come down significantly, at least to half, just because they were not able to take care of the charging cost associated with charging. They ended up having the cost of electricity much higher than diesel. So this is just one example. Oh, for some reason I'm not showing other ones, but there are, and this is not just one, but Albuquerque is another example where they procured the buses, they got the buses, and the buses were not able to do the routes that they were supposed to in their environment. So they had to go through litigations and ended up returning the buses, and then all the hassle associated with that. The same thing, cold weather here, being in Boulder and in Colorado, cold weather is a huge problem with electric buses that needs to be planned for, and you really need to understand what you're getting into. So there have been examples in Chicago, there have been examples in Boston, where the buses are now only able to do half of the route. So what the buses were supposed to do throughout the course of the day, halfway in between, the battery runs out and they have to bring it back. So basically that is again a failure of the project, that now these guys are not operating the buses in winter because the buses cannot do that route. So anyways, that is just to show that is the level of involvement that is needed when you are planning for fleet electrification. Now, this example, what we just talked about, if we are looking at just hop bus electrification, just to show you the scale of a project associated with this. So if we are talking about just 15 electric buses and the charging infrastructure associated with that, the electrical infrastructure and the upgrades associated with that, and the microgrid associated with that, where we are talking about generating all the electricity that is needed for charging the vehicles on site, all of that adds up to about 25 million, somewhere between 20 to 25 million in capex for this particular project. So that is the scale of these projects. These are not small projects where you can afford to make mistakes. These are huge projects, large projects, and hence the mistakes associated with that are also huge and should be taken care of and avoided as much as possible. So what we did for this project was exactly what I explained earlier, that for this route, we went in and installed data loggers on each and every bus. Based on that, we gathered 1 second operational data for every single bus. So the speed trace, that during the course of a day, how is the bus operating every single second. In the same way, how is what is the total distance each of the buses operating for the whole fleet? Then looking at the elevation related information, that again, electric buses, every time it is going uphill, it is spending more energy than what is expected. But at the same time, when it is going downhill, it has regenerative braking and it is able to gather some of that energy back, which charges the vehicle and increases the range of the vehicle. So these are the things which are the complexities which were never came up when you're talking about ICE engine or ICE vehicles, but very specific issues and problems associated with electric. So with that, the idea was that let us evaluate what are the different options of generating this energy. Just to give you some examples, so via mobility, the parking lot and the building. So the different scenarios we evaluated were, let's look at getting the building to net zero, getting the charging 3 buses, 5 buses, 10 buses from solar, generating using solar, and then storing it. So these are the kind of things that we went through in the planning process for this particular project. And I won't get into too much detail today, just trying to give an overview here. So just to take a step back from there, what exactly is a microgrid? A lot of time that question comes up. And what are we talking about in this particular project when we are pointing to microgrids? So a microgrid is an electrical system for a location, say for example, a campus or a building, which has electrical infrastructure associated with it, where you are buying the electricity from the grid. So what microgrid does, or what microgrid is that you have the capability of producing enough electricity so that it can meet your own requirements. So you are operating in the grid connected mode, where you are connected to the utility, but you have the option of generating your own electricity, so you can actually disconnect from the grid. That is what is known as islanded operation or island operation. Or you can just stay connected to the grid, buy electricity from the grid during some parts of the day, produce electricity, sell the electricity back. So all of these things are different options that you can look at. But a microgrid is basically a full system on site or on campus, where you are generating your own electricity and using that electricity on site. So in the grid connected mode, the intent or the goal of a microgrid can be that let me generate my own electricity and use it for peak shaving. So when I'm buying electricity at the highest cost, at the highest rate, at that point in time, let me generate, store, and use my own electricity rather than buying it from outside. So that may be one approach of doing it. Emission reduction definitely is another one, where now whatever electricity you are buying, so you are dependent on the energy mix, and we'll talk a little bit more in the next few slides. So you are kind of dependent on how your electricity provider is producing it. So here Excel Energy is the electricity provider. So the energy generation mix that they have is what determines that what would be the emissions from for via mobility, as an example. So in order to reduce that, you can now have your own solar based or some other sort of renewable generation and use that. So that is for emission reduction. The same thing goes along, as I was saying, integration of more renewables for your possibility. And then the option of if you have to upgrade, because now we are adding electric vehicles. So rather than doing that upgrade today, you can delay that upgrade by bringing in solar and storage upfront and ahead of time. Then in the islanded mode, that is where the utility is not available. So say for example there is some outage, we are again and again unfortunately seeing this, and the number of these events are going up. Flooding, fires, snowstorms, any other sort of storms. So all of these things put together, what happens a lot of times is the grid just shuts off. So if you have an infrastructure that you want to support in such a way that when the grid goes away, I will have my own generation and storage, and I want to operate without the grid also. So that is something termed as resiliency. So that is something which is for which microgrid is perfectly suited for. So there you have to answer questions like, how long do I want to sustain in the islanded mode or for resiliency? So some examples are in this territory, the electricity goes away but never goes away more than an hour. So let me build for resiliency of an hour. In some cases, it may be 1 day, 2 day, or specifically some of the critical facilities like Department of Defense has this specific requirement that they need to support outages for 14 days. So these are the type of things that you have to come up with when you are looking at fleet electrification and microgrids for fleet electrification as well. Specific questions like, say for example, I am on my regular operations, I operate 100 buses. So when there is outage, what will be my schedule? Will I be operating in my full schedule, or will I have reduced schedule? If I have reduced, do I reduce the number of hours, or do I reduce the number of vehicles? So these are all the things that we look into when specifically designing the microgrid for fleet electrification. So with that, I want to welcome Bill Patterson, who's the CFO of Via Mobility, and ask him to share some thoughts that what are their goals, what were their thoughts when they started looking into fleet electrification and also microgrid associated with fleet electrification. And then I'll continue with some more details about this project. Bill, over to you.
Thank you, Namit, and thank you all for inviting us today. You can see here just a few pictures of some of the different types of vehicles we operate at VIA. And if you don't know VIA, we are, as was mentioned earlier, a 43-year-old nonprofit transportation agency. We began our original mission, Boulder County funded VIA, to help people with mobility limitations, most especially older adults and people with disabilities. And that was largely our mission for about the first 20 years of our existence. But as time went on, VIA was asked, being a transportation company, to run other contracted services. And one of those services is the HOP route, which is a fixed route service in the city of Boulder that we call it a circulator. It really runs in a circular pattern, and we run it in two directions, clockwise and counterclockwise, so that someone could go from the Pearl Street Mall to the university and then back to Pearl Street without making the entire circuit. We have run that for the city of Boulder since 1994. Boulder contracts with us for that service. Certainly, the city of Boulder has some very aggressive goals as far as wanting to add resilience in the city, wanting to add renewables in the city, and trying to get to lower greenhouse gas emissions, especially on vehicles. Well, our current vehicle fleet has been diesel, and you all have witnessed and experienced diesel buses and the cloud of black smoke that comes out the back and the noise that's made. And one of our diesel buses is there on the top left-hand side. As the technology has changed, VIA has embraced that and wanted to go forward with electrifying the HOP fleet with the cities as a partner in that effort. One of the things as a finance guy is, how do you fund this? You know, there's a lot of things changing these days, and electrification is certainly a change agent. It's a different type of vehicle. It runs differently. You put energy in it differently. Ranges are very top of mind on an electric vehicle. If you have one, or if you're thinking about getting one, you have to think about, how far will this vehicle take me on a charge, and how and when and where will I recharge it? So those are the types of things that Namit has already been baking into our formulas, and that was part of our thinking as we purchased the buses on the right, which are our newest electric vehicles. Our fleet, our diesel fleet for the HOP, has been 15 vehicles. We have the goal of converting that fleet to non-greenhouse gas emitting vehicles by the end of the decade. And we have started that with 3 new buses. 2 of them are there on the right. They are manufactured by Proterra, an American manufacturer, who, unlike other manufacturers who already made buses and then retrofitted those buses to be electric, Proterra started from the ground floor and designed an electric bus. It's quite a piece of technology. We will also have a large, huge learning curve operating these vehicles. We received these vehicles in February. We have put them out on the route some, but they are not fully out to where they're running every day. And the reason for that is there's just a lot of learning. There's a lot of training for our mechanics. There's a lot of training for our drivers and our supervisors. There's really a lot to know as far as how these vehicles are run. And they're kind of tricky. They're really more a piece of technology than a vehicle. The other half of the coin is the charging infrastructure, as we've been discussing. Where do we get the energy to charge them, and where do we get the money to buy the chargers? The vehicle on the left, the diesel bus, our cost on that is between $400,000 and $500,000. Our cost on an electric bus is about $850,000. And that does not include the charging. The charging itself, not only are the chargers, the fast chargers, relatively expensive, but installing them and getting the power to them is also expensive. So it's a facilities issue, it's an electricity availability issue, and it's a purchasing the vehicle issue. All in, you're more than double the cost. Our traditional funding model for buses has been federal funding. VIA is eligible for that. And buses are replaced on a schedule. They have an estimated life, and you can get federal money for those buses, but then you can't get more federal money to replace that bus until it's reached its useful life. So traditionally, we have received about 80% of the cost of the bus, and then we provide what's called local match to make up the other 20%. The electric buses, of course, being twice as expensive, not as much federal money available. There are some other creative ways that state funding has helped with that, but all in, we have had to come up with more local match, meaning VIA's money, the city of Boulder's money. RTD has been a participant in helping us fund these vehicles. But that's going to be a continuing challenge as we go down the road. How do you double the cost of a fleet and maybe add another 25 or 30% on top of that for charging, and be able to replace all these buses out there over the next decade? I mentioned range earlier. We have determined on our routes that we can probably produce this route for about 250 kilowatts. And so when you think about that, as Namit said, about 10 times, 20 times, what it would cost to run a home. We have decided to go with 440 kilowatt buses for a number of reasons, one of which the batteries will start degrading from the day you buy them. So eventually we may only end up with about 80% of that chargeability. And at some point in the useful life of these buses, we may have to replace the batteries. But we wanted to cook that into the formula. Well, these batteries will degrade some. We need to think about that. And then temperature is a big thing. Not necessarily how the batteries work with temperature, but how you're using the battery. To put heat into the bus, we decided to use electric heat. There was a diesel heat option, and we really want to keep that greenhouse gas to zero. We want a zero tailpipe emission out of this vehicle. So we have chosen electric heat, and we added battery power to run that heat. Similarly with air conditioning. So on a hot day, on a cold day, you're going to use more energy. On a, let's say, 65-degree day, you're going to get a lot more range. So we bake that into the formula for the sizing on the batteries. One thing I will mention, you see these other types of vehicles. We have automobiles, we have some small vans, some what we call cutaways or bodies on chassis. The one there in the left-hand center. This is the next wave. We've already begun buying electric automobiles. We have a grant for our first electric cutaway vehicle. And again, that's going to be challenging. At least on a bus, there's a lot of room to put batteries, less room on a cutaway, even less room on a car. Now, some of the autos now are getting 200 and 300 miles of range, which is more than enough for us to run a day. The cutaway may only be about 120 miles. So we have to really think about what we're going to use that vehicle for. And again, as that battery begins to degrade over the first 5 or 6 years we own the vehicle, we'll have to build our routes around the capabilities of that battery. We also, have hope that the technology will continue to improve and give us better range on future vehicles. But as opposed to 15 buses that we need to replace, we have somewhere over 100 other vehicles that we also would want to electrify. So let's go on to the next one, Namit. Our facility is also an energy user. That's a picture of our really beautiful facility in Boulder, built in 2010, and it was built as a very energy efficient building. You can see all the windows, which provide us with a lot of natural light in the daytime. Hence, we don't have a huge demand for lighting. Of course, it's all lit up in the picture, but during the day, we don't need a lot of lighting. We have other pretty efficient systems in the building, but still, we use a fair amount of energy every day there. That with the building, we put in about 100 kilowatt solar array on the best roof we have, and you can see that on the bottom left. That has served us to the tune of about 20 to 25% of our energy use on the building, so that's been very helpful. We've also put in a critical load microgrid. You can see there in the center. We've added some additional solar and some battery that we use to run our IT room, but we still have a long way to go. And one of our goals is to have enough power generated on the property to make our building a net zero facility. In other words, we either generate and use or generate and put back to the grid enough power to power our building. We have the further goal of net zero on the hop fleet as well. So 15 buses in the building, net zero. Let's go on to the next one if we could. And I think, I can turn it back to Namit here in a moment, but we really are looking at many options here. We also need to be resilient. We need to provide services. We have provided services for forest fires, floods, emergencies in the city, and in the neighboring 8 counties where we operate. So we have to have resilience. We have to have electricity. We have to have a building that operates, and we have to have vehicles that operate. So it's going to be a combination of grid, self-generation, storage, and backup power. And Namit, let me take it back to you, and then I'll, come back at the end for questions, if that's fine.
Sounds good, Bill. Thank you so much. Just to continue with what Bill was saying, that so what we did was, during our analysis, really looked into all the existing electricity consumption that is going on at VIA, and at the same time also a phased plan for electrification of transportation, because as we mentioned earlier, the moment you start talking about electrification of medium duty or heavy duty vehicles, then 1 or 2 vehicles is enough. That is what becomes pretty much equal to your whole building consumption. In this case, the building is pretty large, so the 3 or 4 vehicles, that is what is equal to that building. So now when you're talking about electrifying 120 or 130 vehicles, so you are really talking about all of these things at a completely different scale. So on the left here, you can see that, as I mentioned earlier, that VIA is buying electricity from Xcel. So whatever they buy, that is actually dependent on how Xcel produces it. And here locally, Excel has a mix of natural gas, coal, wind, very little bit of solar, hydro, and other sources. So for that mix, for Excel, the CO2 emission number per metric ton is 0.552 metric ton per megawatt hour of electricity purchased from them. And they have a goal of 100% carbon free by 2050. So what this means is that the electricity that VIA purchases just for the building accounts to about 360 metric tons per year of CO2. That, having said that, VIA has added about 97 kilowatt, close to 100 kilowatt of solar, so that offsets about 20% of their electricity consumption, which is already produced on site. And the goal is to get to net zero, as Bill was mentioning earlier, and flip this the other way around so that you are not buying anything or buying, but end of the year you are at least net zero. So that is the goal for the building. So that's what we were aiming at and started with. Now looking at the transportation side for VIA, so they have 135 vehicles, operate about 1.5 million miles. So this is now split between the heavy duty fleet, HOP, what we talked about, the medium duty fleet, and the light duty fleet. So even though the medium and light duty fleet does the maximum amount of miles per year, you can see the emissions from the diesel is still very close to what all the other vehicles. So this is just a fleet of 15 vehicles, and the other one, everything else, is about 120 vehicles. So the emission numbers are very close between these two. So that even more justifies that we need to electrify the diesel fleet as soon as possible. So the goal that VIA has is 25% of their fleet by 21, and this is where they are right now with 4 electric buses. 50% by 2023, so this is in discussion for more buses coming in, and absolutely 100% by 2030 for the HOP fleet. Along the same line, the rest of the fleet looking at about 25% by 2025, 75% by 2030. And one of the main restricting points here is unavailability of medium duty fleet. So the cutaways that Bill was talking about earlier. So in today's date in the industry, there are a few but not many manufacturers who are actually building these from the ground up. So they actually buy these vehicles with engines, take out the engine, then replace it with the electric transmission and batteries associated with that. So the cost of these vehicles are very high, and the range is not to what is needed. So that is one of the reasons of slowly transitioning these vehicles. And also the goal is that after 2030, VIA will not purchase any more emitting vehicles. So any purchase made after that will be zero emission. So we've been operating in different phases. So as Bill mentioned, the building was built in 2010, 2011. So it is sustainable by design, already has rooftop solar. Then in 2018, VIA started transitioning towards electric. So they got their first electric bus, which was one of the diesel buses where the engine needed to be changed. So they retrofitted it with complete electric. So this is 100% electric. You guys might have seen it, at least for the people that live in Boulder, might have seen it. It is regular on routes. And they did on-site microgrid for critical loads for their IT facility. Then currently we started working on a very detailed fleet electrification plan and a microgrid plan. That's where we are right now. We are finishing that, and as Bill mentioned a few months ago, they got the 3 more electric buses. So this makes the HOP fleet to 4 electric buses. Moving forward, the goal is that with these 4 electric buses, the fleet is now 25% electric, and the goal is moving forward in the next step to get the building to net zero and get these 4 buses to net zero. So this is how the layout is right now. The next step is cover the rooftop solar and also a portion of the carport solar, so that the fleet that stands under it, the charging infrastructure, everything there, that is covered, and you're producing enough electricity to get the building to net zero and get the buses to net zero as well. So as Bill mentioned, the goal is also kind of stepwise, that for the vehicles, absolutely first step is let us get to zero emission. And that is why electrifying the fleet. And the next step from there, as we saw earlier, that then it is dependent, your emission numbers are dependent on your electricity provider or the utility. So in that case, if you are able to produce enough electricity using renewables, in this case solar, and put that electricity back on the grid, so that whatever you are buying, the same amount you are producing and putting it back, and hence the term that by the end of the year, or when you look at the whole year, you are able to get to net zero. So the goal is to do that for the building and also for the fleet. So this is what the plan is, to achieve this by 2025, and then moving forward by 2030, the plan is 100% of the hop fleet will be electric, and rest of the fleet. And that is where also the plan is to cover the whole facility with roof carport or busport solar, and maximize the generation on-site, local, renewable-based generation as much as possible. So cover it up completely. So that way, the hop fleet gets to zero emission and net zero, and the building gets to net zero, and we have on-site storage as well available, which creates resiliency for the building and some of the buses. So that is overall just the high level of this project, high level of what microgrids are, how microgrids tie into fleet electrification, because now this is your captive requirement of electricity, and a perfect combination that now you would be transitioning away from diesel or any type of fossil fuel vehicles to zero emission. And the next step from there is, let us produce your own electricity, so you can get from zero emission to net zero as well. So that is the overall concept. That is the project that Via Mobility and City of Boulder have taken on, and this is where we are at this point in time, and moving forward, that's what the goal is. So that's it from my side. We really want to thank CRES for allowing us the opportunity to come here to talk about this. Open for questions or any feedback from anyone in the audience. Thank you again. Chris, back to you.
Absolutely. Yeah, thank you, Namit. What a wonderful presentation. Okay, we'll hop into the Q&A, and we'll just jump right in. First question we have here. Let's see. What possibilities does vehicle to grid capabilities create in fleet electrification?
That's a good question, and that is something which keeps coming up a lot. So on the technical side, the vehicles that, at least as Bill was mentioning, the Proterra vehicles, the interesting thing about them is these were built the ground up for electric. So technology wise, these are one of the most sophisticated vehicles in the industry. So technology wise, they are capable of vehicle to grid, where the battery on the vehicle can push electricity back into the grid. The chargers that are installed, we are exploring that option. So the bus or the vehicle has to be capable. The charger has to be capable for the reverse flow of the electricity, and then the next step from there is the building or the grid should be capable of receiving it. So here the buses are capable, the chargers we are in discussion to explore that, And then the point is that is the grid, because in different geographic locations, different utilities have different policies. So at this point in time, Excel Energy does not allow that feedback, but that's the technical part of this. The other part of the question is that is V2G even feasible, or is it even possible? Is it a good idea, so to say? So the challenge there is that hop buses, as an example, so they are on route throughout the day. So there is absolutely no way that you can plug it somewhere and provide the electricity back. So that is out of question. Then the buses come back in the evening and they are charging throughout the night, so that they are ready to go back on route the next morning. So again, the point is that during that course of 7 or 8 hours at night, the buses are now being charged. So the question of them discharging is kind of out of question. So case by case, there are some scenarios where V2G is feasible. Most of the cases it is not. School buses is one of the examples which the industry is exploring, that school buses are parked in their own parking spot pretty much throughout the day. They go pick up kids, drop, come back, stand there, then do that again and stand there, and they are there throughout. So school buses are considered to be one of the candidates for V2G. But usually what we've seen is in the transit industry, it's not the best option. But again, like it depends on the use case. Technically, technology wise, all of these are capable, but use case wise, at least here in VIA, we are not considering that. But we are looking at testing the technology, so that moving forward, you might have some different scenarios that you might consider, that now you have some extra buses that are now charged. So that can actually, because the electric buses are basically battery on wheels, right? So now you have this huge battery pack which is on wheels. So you can send it somewhere else, and this can provide uh, emergency electricity to some other location, maybe hospital, maybe some other center, other critical facilities. So from that point of view, we are on the technology side, we are making sure that it is V2G capable. Sorry for the long answer, but yeah, this is a topic which always comes up.
Sure, I can imagine. Okay, what is the total cost of an electric bus over its life versus a diesel bus? Are there meaningful savings in maintenance and fuel?
I could
Yes.
take that one, Amit, if you.
Yeah. Go ahead, Bill.
You know, the manufacturers will tell us that over time, the electric bus, although it costs twice as much upfront, the capital cost, that the maintenance costs and the operating costs will be lower. And I think there is some, we don't have enough experience with that yet, but I think there's some evidence that's true. There's just a lot fewer moving parts, or not a lot of fluid, not a lot of things to replace as there are in an internal combustion vehicle. But that said, the one thing that Namit put up early was the case study that RTD had, where in fact the electricity cost was so high that it drove even though the maintenance was lower, the operating cost for the fuel, being electricity versus diesel, was higher. And that's one of the reasons we're looking at this project, is we need to get control of our electricity costs. And whether we peak shave, as Namit said, or whether we can generate enough of our own power that we're sending back to the grid, and possibly use some amount of battery electric storage, get control of those costs so that we're not paying huge demand charges. I think too, we will see over time that the utilities will have allowances for fleet charging that will make our electricity more reasonable. But I think that's going to be the biggest thing. When you look at the capital costs for this technology versus the capital costs for the old technology, it is substantially higher, not only in the vehicle, but in the charging infrastructure needed. So we will see. That's, as a financial guy, I want to be environmentally sustainable and financially sustainable. And if we can make that model work, you know, we're not a huge agency, but we could scale this up, or it could be scaled up for much larger agencies, and that's what we'd like to see.
Perfect. All right, next question. What is the daily running and charging cycle of a hot bus?
So
Running
approximately 7 a.m. to 10 p.m. Runs, and then comes back and charges from few minutes after that to few minutes before it leaves. So let's say 1 hour after that to 1 hour before it leaves. Bill, is that anything you want to add that?
Yeah, I was just going to say that's also been part of the formula that we've looked at here is how many buses can we charge overnight by utilizing our power efficiently. And this is one of the early things that other agencies ran into, where they'd bring all their buses back, plug them in at the same time, run up a huge demand charge, and then they'd be charged by 1 o'clock in the morning, and your power would go back down to just running the building. So you just spiked it. And what we're hoping to do is be able to spread that charge out over the course of the evening from that 10 p.m. Some of the buses even come back at 7 p.m. So what's the smartest way to do that to even that power usage out? You know, it could be software hooked to the chargers. That technology is not quite there yet, but we're looking into that. But to me, that would be the best and most efficient way, and it's going to keep our demand charges down. We have our biggest charger right now is a 125 kilowatt. So if that bus is pretty darn discharged, you could still charge it back in about 3 hours. So the time you have overnight, you could charge 3 buses in series, one at a time, and get them recharged overnight with that charger.
All right, next question. Are exchangeable batteries currently available for fleet vehicles? How would that affect fleet electrification?
That is a good question. Bill, you want to start on that, or I can start on that either ways?
You know, they're not. Yes and no. So this bus, as we mentioned earlier, it's built from the ground up as an electric bus, and this particular bus has 4 battery packs. They're quite large. They can be replaced, and ultimately, I think that's what will happen. We have to have this bus last us for 12 years before we can, get the funding to replace it. So we purchased a battery warranty from the manufacturer, which guarantees over the life of that bus that it will perform at least 80% of its original capabilities. I think what will happen in the future is particular battery packs will be removed, sent back to the manufacturer, and they'll just have replacement packs that go in. So I guess the answer to the question really is yes, those batteries can be replaced and exchanged. But I would say each battery pack got to be, I don't know the cost, 80 to 100,000 is my guess.
Yeah, and sometimes that question comes in reference to whether these packs can be changed or exchanged on a daily basis, so that now you have extra set and you are reducing your charging time by charging the battery packs on during downtime. So some of the OEMs are actually exploring that as well, that the battery packs are designed and placed in such a way that these are heavy, so of course you cannot manually move it, but using a forklift or something, you can take that out, so that then you just have extra battery packs in your garage, and you are utilizing that for managing the charging. But some of them are doing that and going in that direction. But overall, as Bill mentioned, that these batteries on these buses have a certain life, and it is expected that by the end of it, these batteries would be again about 80% of their energy capacity. so they are termed as not fit for a vehicle or road, but still those batteries will have 80% capacity available. So the thought is that that's the second life of the battery, that now you can take that out and use it for stationary applications like supporting the building or powering the building or anything of that sort. So that is what the overall industry-wise the thought is, that when this battery gets to a point where it has degraded by 20% and down to 80%, so that is where you change it. And I guess to answer the question and what Bill mentioned, most likely because there are no other parts, hopefully there are no other parts in the bus that would go bad or need to be changed. So you just go and change the battery and the bus is good enough to go, keep going on and on. That's the promise of the electric vehicle, million-mile vehicles. So let's see how that happens. But
Okay, next question. Have you considered the idea of distributed citizen-owned electric vehicles for your fleet? I'm thinking that this is a great way for people who own electric vehicles can be contracted to meet the transportation needs of seniors and disabled members of the community.
interesting one. Bill?
That's a very interesting question.
That's a very interesting one, yeah.
We haven't considered that, but it is almost, there are models out there like Colorado Car Share, for example. Now they own their own vehicles, but could you consider utilizing somebody else's vehicle? I've seen this on rental cars where people are actually putting their own cars out there, sort of like Airbnb for cars, and other people rent their car, bring it back. So certainly possible. We do use some number of autos. Would people actually have the larger vehicles we need for wheelchair transport and that type of thing? Probably not, but that's a very interesting idea. I like it.
Yeah. And I would suggest whoever put that question, do get in touch offline and maybe you can explore it more. Do share your ideas.
All right, next question here is, what utility rate structure is the most favorable for EV buses?
So currently this location has the secondary general, and we did some analysis looking at if you stay with this or you switch over to utilities are now coming up with their EV rates. So those as another option, and then since looking at the size of the grid that this is now becoming into, or any of the fleets, most likely if you are operating medium to heavy duty, so the size of these feeds coming in, so that is where you can also look at switching over from the secondary connection to maybe going primary, but in that case you are kind of becoming a utility where now you will be responsible for all the maintenance and everything for the transformer. But anyways, let me not get into that detail. But the most cost effective seems to be stay with secondary general, but have your own generation and have your own storage, and at the same time manage charging. So that way now you have the flexibility with the on-site generation and on-site storage and controls to be able to control and play around with the time that you purchase electricity and the power level at which you purchase, so that you are now able to control and maintain the cost. So so far, based on the analysis, if you have controlled charging and some storage and some generation, then you are able to manage it to the lowest with secondary general.
Great. And we'll just do a couple more questions here. So the next one we have is, as fleet size increases, so does the stress on existing charging infrastructure. How does this alter optimal routes and schedules in the future? Is there a plan to also expand the charging infrastructure capacity?
Short answer, yes. As the fleet increases, the charging infrastructure will increase, and all of those things are taken into consideration because we look at the feeder, in this case again Excel. So they have a overhead feeder, a 13 kV line that goes from there, and the existing infrastructure from there. So all those things are taken into consideration when we are designing all this. And Bill, over to you for route related information.
Yeah, I mean, our charging is going to be at night by and large. We run our vehicles all day, and some vehicles, but still the timing will be important. Some vehicles come back at 5, some come back at 7, some come back at 10. So, and then, you know, when do they go out in the morning? So there is some leeway we have there, but again, trying to even that load over the night and utilize the power that you have most efficiently. Ultimately, I think it's going to be software that does that for us, and better technology on, you know, charger controllers. We're still early on there, and I know Namit has some wonderful ideas around charger controllers. So I think that's going to be our saving grace for the efficiency.
Yeah, so basically we're looking at all the options and all the scenarios when we are evaluating everything, and based on that the decisions are made.
Got it. Okay, we'll do one more question here. This is a relatively quick one. Well, maybe. But why won't Excel let vehicle batteries be used to feed the grid?
So that's a policy question. So here in Colorado, so far in Excel territory, it is not open, so to say, where you can sell electricity. I mean, you can sell electricity, but you can take part in other services, ancillary services, and V2G is one of that, which is not 100% clear at this point in time. So again, even all of this is so new that even the utilities are constantly upgrading, looking at all of these things to see that how it affects and what would be the long-term consequences of that. So they are in the process of evaluating all these things. So I think it's a matter of time.
Perfect. Well, Namit, Bill, it's been an absolute pleasure tonight. We really appreciate you guys coming to speak for BCRES. Again, greatly appreciate all the work you guys are putting into this, and we hope to hear from you guys soon. But yeah, that's really all we had for tonight. Unless you guys have anything else you want to add, we'll conclude the webinar.
No, nothing from my side. Thank you so much for this opportunity. Really, I think this is a great project, local project. So anyone that wants to get involved or know more about it, feel free to reach out. I should have put my email address, but if you can, Chris, if you can send out mine as well as Bill's email address, that would be great. If anyone wants to get involved in this project.
Yep, we're happy to provide, you know, more information if you're interested. And as Namit said, this is an exciting project. We're very we're just thrilled to be able to go forth with this. And of course, it's going to take additional funding, and we're looking for that funding. But the plan is coming together, and I think we'll get it done. Thank you all for your time tonight.
Yeah, and if
thank you guys for the work that you do.
Yeah, if there is anyone, because there are fleets, there are other people who are looking at electrification. So even if you have any questions, we know that this is not a easy transition, and there are so many questions that need to be answered. So absolutely feel free to reach out.
Absolutely. Well, guys, thanks again so much for being here tonight. Thanks to everyone in the audience for being here tonight.